Okay, so multiplying terms, with specifically we're going to focus on those indices or exponents or powers. Because we know from our work with expanding, we know what an index does, right? What it is it's simply repeated multiplication. But instead of writing x times itself this many times, I can write x to the what? To the power of 6. Excellent. Okay? So remember that all that an exponent is simply repeated multiplication with the same base.
What's index?
Index, the same thing. Index is just another word for exponent. Index, exponent, power all mean this exactly the same thing. Now, be careful.
Be careful.
Base. Be careful, base. Base, right? We've seen base when we talk about a term. What is the base when we talk about a term? The variable. There you go. But does base always mean variable? No. It's called a base for the term because it's the thing that everything is built on. Right? Okay. Ever play softball?
Yes. No. Yeah.
Okay. You've heard of it though.
Yes. I played it.
What are those things called that you run around and step on and stay on?
Base.
Right. Totally, completely different thing, right? So does the word base always mean the base of the term? No. Exponents have bases too. Let's say we have some a to the n. This is exponential notation written in what's called general form. Get used to general form. General form simply means you're using letters instead of numbers. Because A stands for literally any number. N stands for literally any number. Okay? They can be anything. So use variables to represent things so that you can write a rule. A is the base of the exponent. And n, in this case, is the exponent. So hopefully that's not new to you. That you have a base and you have an exponent, right? And it means to take the base times the exponent, right? I'm setting you up here. No. It means take the base times what? Times itself over and over and over. The exponent only tells you how many times you multiply that base times itself, right? So be careful. Lots of students want to do this business. 2 to the third power means 2 times 3. Is that correct? Nope. 2 to the third power means 2 times itself. How many times? 3 times, which is 8. Okay? So be very careful. One of the problems that students have with algebra is they don't slow down and think about what's in front of them. I know that none of you have ever made this mistake of just jumping to a conclusion, right?
I have.
Maybe once in your whole life, maybe, okay? Yeah. That is the biggest problem in mathematics. You glance at something and you think it's something else. Okay, so you've got to be careful. So slow yourself down. And one of the ways you can do that is always by saying, what operation do I have here? Because that slows you down enough to think about what rules you'll need to apply. Okay, now today we're going to talk about multiplying with indices. And we've seen this before, and I've actually even given you the rule for this because of my inexperience teaching at this level. I thought the rule is so easy, let's just do the rule. But apparently I've been corrected. Say we have x times x times x times x times x. This is what's called expanded notation. And remember we did this when we did the division? We used expanded notation because anything divided by itself turned into a what? 1. And you didn't need to write the ones, right? Because there was something else there. So this is expanded notation. So let's write this as exponential notation. Notice that I have these two x's grouped together. It's x times x. What would that be as an exponential notation? X to the what power? To the second power. Times, now here I have another group of x's. How many groups of x's do I have there? 3. So that's x to the third power. And I still want to multiply those two things together. Well, if you look at the top and just count it all out, it's all multiplication all the way across, right? Do you agree with that? Then there's 1, 2, 3, 4, how many? 5 of them, right? So that's the same as x to the fifth power. Well, what could I do to this 2 and 3 to get that same x to the fifth power? Simply add them. So anytime you're multiplying with exponents, to multiply exponents on the same base. And that's the key. They have to be on the same base. So what if I'm multiplying x's and y's? Can I do this? No. It's got to be x's and other what? X's. 5's and other 5's. Y's and other y's. That's the key. All we're going to do is simply keep the base. The base will not change. And we're going to do what to those exponents? We're going to add them. Now, here's where I'm going to be mean. Because this is such a critical skill, and at some point in your algebra career, you need to see this and go, boom, this is it. This is all I need. I need to do this. I need to know exactly what I'm going to do. So I am going to right now make you write it my way. All right? And I'm going to come around and look. Because it's that important. So when you're doing your homework, I insist that on your page, because you can write on Education Perfect if you want, or you can use a piece of paper, but I insist, guys, is everybody listening? That you write it the way I'm about to show you, or I will delete your score and make you do it again.
What?
Yes.
I don't agree with this.
Oh, ask your mother how she feels about you doing things the right way, and then we'll talk.
Well, who says it's the right way? It's only your way.
Yeah, it's your way, so it might not be the right way.
Who's studying math? Me.
Who else here?
Technically, we are studying.
Who else here has a master's degree in math?
Me.
Gee, Sophie.
You're all. All right, then why am I here? I should just go home and collect my check. Okay, just do it because it'll make your life easier in the long run. And isn't that my job?
Yeah, maybe.
Okay, it really will make your life easier in the long run. So let's go back to that same problem. Say we have x to the second times x to the third. I know that many of you are going to say, oh, all I need to do is add those exponents, so it's going to give me x to the fifth power. And that's where eventually I want you to be. But not all operations do you add the exponents, only when you're multiplying. So to reinforce that, here's the way I want you to show me the work. Okay? It's x to the 2. Do I have the same base? Yes. The first exponent is a 2. Since I'm multiplying, what am I going to do to the exponents? Add them. And the second exponent is a 3. And x to the 2 plus 3 gives me x to the fifth. Now, I know it's not a huge, I know it's an extra step, but you can deal with it. What am I trying to get happen here by adding that extra step? Makes you what? Focus on the process, right? By adding that extra step, it reinforces that what you need to do is add those exponents. Because later we're going to look at an operation where what you have to do is subtract those exponents. And then later we're going to look at an operation where what you have to do is multiply those exponents. So do you see what's happening? There are going to be all kinds of different things that you have to do to the exponents. So you need to associate which one. And the association is not quite clear here because the original operation we started with was multiplication. But did we multiply those exponents? No, we added them. So the multiplication is not the same as what you're really going to do, right? You're not really going to multiply. So it just keeps you focused if you'll do it this way. Now, after this one lesson, I'll never ask you to do it again. But for this lesson, I want to see that step. I don't think that's asking too much. Maybe? Oh, well. Even if it is tough, I'm the teacher. Okay? Now, so let's say we have y to the third times y to the second times x to the second times x to the fifth. What operation do you notice all the way across? Multiplication, right? And so that's good. Now, so what I'm going to do is I'm going to take y to the 3 plus 2 plus 2 plus 5, right?
No.
Why not?
Well,
Well,
he had a something in back.
I'm messing with you. Remember that we can only add the exponents when the bases are the same. So for the y's, I can take y to the 3 plus 2 times, then we have the x's, so that's x to the 2 plus 5, which gives me y to the 5th times x to the 7. And what our rules for simplifying in algebra means that I don't need that multiplication, do I? No. But what else does my rule for algebra say? That what? Which one of those things should come first? So is y to the 5th, x to the 7 my answer?
No.
What's wrong with it?
X to the 7th and y to the 5th. In alphabetical order.
Because you always put, if you have more than one variable, they have to be in alphabetical order. Okay? Right? Now you could do this middle part and then get to there, but you need to get to there. Now I'm going to warn you, Education Perfect will let you type it backwards. But am I going to give you credit for it backwards?
No.
No. And you'll see why when we start combining more like terms, etc. Okay? How does it look? Pretty darn easy? Easy, right? Okay? So, let's go to Education Perfect and do what they have us do. So in this lesson, we're going to talk about multiplication and division. We're going to save the division to later. We're just going to focus on the multiplication. So your assignment that you're going to have on there is just the multiplication. So one of the things about it that you need to understand is you need to understand about exponents. So we talked about that. 2 times itself over and over and over, right? 2 times 2 times 2 is the same as 2 to the third. Now notice the top one. We've talked about this notation. If you don't have an exponent, what do you assume that exponent to be? A 1. So does that mean everything has an exponent?
Yes.
Absolutely. Right? So what is the exponent on just plain old y? A 1. And I need to know that because I can't add it if I don't know what it is, right? Okay? So, good. All right. And remember, the base is the thing that tells you whatever you're multiplying, and the index tells you how many times you're multiplying it. Okay? So, we can always write multiplication by the same base using an exponent, but it's got to be the same base. But what if we multiplying them if they have the same base? Do we multiply those exponents? No. What are we going to do to them? Add them. And we're going to write down the addition? Yes. Just this lesson. Okay? That is like one annoyed cat. His teacher has probably made him write down the addition part of it too, right? So I know. Y'all don't like it, but that's just the way it is. Okay? So they're just demonstrating what I did. You'll see they expanded it and then just counted it up to show you what you would get if you just expanded and counted it up. But instead of doing that, you can simply add the indexes and get the same answer faster, right? No, you don't need to. Yeah, they're not. Well, it means you need to do that, guys. It means you need to do that first. But it's the only thing to do, isn't it? So you're going to do it first anyway. All right. What if you have more than one base? Do you think it'll change the process? No. So m to the second times m to the fourth times m to the no exponent, which means m to the what? 1. Just means take them all and add them up. All right? But again, I want to see this step for this homework. Okay? All right. So, go. Do it. P to the 5th times P to the 3rd. And I want you to write it out the whole way. So in your notes over there, you computer users, I'm going to come over there and see it typed in right. P to the 5th times P to the 3rd. Okay? We got it? Yeah. All right, so answer my questions in the order I'm asking them, and everybody can just sing out. I'm not going to call on one person or wait for you to raise your hand. First of all, the most important thing I can do is determine what operation it is. What operation is indicated here? Multiplication. Excellent. Good. And I'm multiplying things that have the same what? Base. And I know they're the same base because they're both a P, right? Yeah. And since I'm multiplying powers with the same base, what am I going to do with that base? Keep it. And then what am I going to do to the exponents? So what are the exponents? 5 plus 3, which gives me a completed answer of P to the 8. There you go. See how easy that is? Now, but, what happens when something is easy? How much attention do you pay to it? 0. No attention whatsoever, which is why I'm making you do this. Because it's such an easy thing that we think, oh, I'm going to remember that for the rest of my life because it's so easy. And then guess what happens? You don't. Right? And I know because I've graded about 60 billion math tests in my life. Well, maybe a few less.
Have adults ever taken your course?
Oh yeah.
So you've taught postgraduate before?
All right. Okay, ready? So there we go. They're just showing it to you with the shortcut way, right? And then they're showing you the expanded way just to confirm it, right? I don't care if you don't have to do that, but I do want to see that part of it. Okay? So I don't need to see the expanded. Okay? But it makes it a lot easier. Now, look at this one. We have different letters. Do you think that changes things?
Yes.
It changes it slightly. I can't just add every exponent I see, can I? No. But I can on which letters here? The F's. The F's are the same base. So that's the same as F to the, what's the first exponent?
2.
Plus, what's the second one?
3.
Which gives me F to the 5th. Now what about the G? Just plunk it down beside it. Why?
Because the G doesn't have another.
It does, yeah. It's another base, right? And so all I'm going to do is stick them side by side so that I represent multiplication. And does F come before G in the alphabet?
Yes.
There you go. So, yeah, in most alphabets, yes. Yes, it does. So, F, 5th, G is your answer. Okay? So if you have another base and it doesn't have any more exponents, then just plunk it at the end or in the beginning, depending on if it's alphabetical order, right?
Yeah, G totally.
Okay. So there you go. F to the 5th G. Okay. Everybody go. Remember. Oh.
How do you do these two at the top? Do you just add those? Just ignore it.
Those same bases you can add, right?
Yeah.
Okay.
Oh, what order do they do in the alphabet?
I don't know.
Hey,
Sing the song. All right. Are we ready?
yes, I'm ready.
Come on, it's easy. Okay.
Okay. So the most important thing I can do is identify the operation. What operation is indicated here? Multiplication. Okay. And when I'm multiplying, if they're like bases, I can keep the base and do what to the exponents? Add them. What is the first base you see?
H.
And then there's another h, isn't there?
Yeah.
So it's h to the what? 2 plus 4 gives me h to the 6. What's my other base? K. So k to the 3rd plus 5 is k to the...
H.
And now since they're multiplied, I'm just going to stick them side by side, but in what order?
H6.
The H comes first because it's first in the alphabet. And there's your completed answer.
I wrote it as HKT. So I added a little bit to this.
So you just put, yeah, be careful. Because literally, HK is H squared times K to the 3rd. So remember, you just have that multiplication, that multiplication is assumed. So even though they're stuck together like that, they're not really one thing. Okay? Ella, did you see that? See, even though they're stuck together like that, they're not really one thing. Okay? So be careful about that. How's that look? Okay. Excellent. And then they walk you through that. And there's the expanded one. How would you like to do that?
I love it.
Whee! No fun. I don't like it. Okay? Yes, you can, because we've got a little bit more. Because what happens when we throw the numbers in? Because remember that algebraic terms aren't just letters, are they? But remember, what could you always do with numbers? That's just arithmetic, so you can always just multiply them. So is putting the numbers in mean you're going to add more exponents?
No.
Nope, it just means before you start working with the letters, you need to work with the numbers. Because remember the 4 parts of a term? What are they? Sign, coefficient, base, and exponent. And you always deal with them in order. So, always determine the sign first, but all of these are positive. When you multiply with positives, you get a positive. But it could be a negative. What's a positive times a negative going to give you? A negative. Remember, we've talked about the sign rules. Then the coefficients. Which coefficients of a term means which parts? The what? The number parts. Don't get me started. Night at the museum. All right. And then we keep the base and do what to the exponents? Add them. So here we go. Positive times a positive stays a 3 times 5 is 15. M to the 2nd times m to the 4th is m to the 2 plus 4, or m to the 6. Now notice I still took that off to the side and did it. I want you to as well.
Maria said 3 times 5 is 14.
Well, she was darn close.
No,
Okay.
it was 15. I said
Just don't let her ever write your paycheck. And you'll be good. Now, do I need the plus? No. Is it wrong if I left it? No. Okay? All right. Okay? So, at multiplying numbers, there it is expanded. What fun would that be? Okay. Go. Here it is, piece by piece. Okay. Here we go. So let's do this one. Go, guys. You have 30 seconds.
No, please.
Karen.
What are you?
Done.
Wait,
Yeah,
I'm
I'm
writing
writing
it
it
out.
No, you probably didn't do it right.
Okay.
Oh, wait.
That's not very kind.
Rhea, this one is 14, just letting you know.
Yeah, Rhea. Just if you get confused about everything.
Stop that.
Guys, you're giving everyone the answer.
It's 14 but
I think they already know what 7 times 2 is.
I know
So
what
mine
it
is
is.
not.
Wait, this is self. Is it just the same?
It's 15, guys!
Just multiply the numbers.
Mr. Selby, you should check everyone's notes today.
I am.
Yes.
Okay. All right. Let's see. Are we ready? Here we go. First of all, what operation is indicated here? Times or multiplication. You bet. Y'all say times more than multiply. It doesn't matter. It means the same, right? It's okay. If I'm multiplying algebraic terms, the first thing I needed to do is determine the what? Sign. But these things, both of these are positive, aren't they? So a positive times another positive just stays a positive. Are they always going to be positive? No. Maybe not. Guys, hey. All right. Second thing I need to do is work on the what? Coefficients. What is my first coefficient?
7.
Times my second one is 2. 7 times 2 gives me 14. What am I going to do with the base? Keep it. So it's going to be a t. But what do? I'm multiplying. So what do I do to the exponents? Add the exponents. So I want to see that off to the side. It's t to the what?
3 plus 7.
3 plus 6, which is t to the 9th power. All good?
Yeah.
How easy is algebra? Really? Come on. Okay? Now, do I have to have the plus in front? Guys? Do I have to have the plus in front? No, but it's not wrong if you leave it. Okay? All right. So, next time we meet, we're going to work on the division, right? And the division algorithm. Now, it is a little, and you're going to see why, when we do the division, why it's so important to do this step. You don't really see it as much with the addition because you're so used to doing addition in your head, right? But you're really going to see why I insist on you doing that step when we do the division parts.
Why?
Okay?